Hello students, welcome back to the fourth lecture on Poisson distribution. In the previous class, we have started solving the examples on Poisson distribution. In continuation with that, today we will solve some more 5 marks examples on Poisson distribution. Here today's first question is, it has been found that on an average 4 patients visit a particular doctor during 1 hour. What is the probability that during a particular hour, first sub question, doctor is free, and second sub question, more than 3 patients visit the doctor? Read the question carefully and find what is given in the question. Now in the solution, we will denote x, that the number of patients visit the doctor. X is nothing but the number of patients visit the doctor. Therefore, x follows a Poisson distribution with parameter lambda equal to 4. Because it is given in the question, it has been found that on an average means mean is given, mean of Poisson distribution, and on an average 4 patients visit a doctor, means lambda is equal to 4. Therefore, we will write the PMF, that is probability mass function of Poisson distribution. That is P of x equal to, general PMF we have e raised to minus lambda into lambda raised to x divided by x factorial, where x equal to 0, 1, 2, so on infinity. Now in this PMF, put lambda equal to 4 and write the PMF, that is P of x equal to e raised to minus 4 raised to x divided by x factorial. In this general PMF, put lambda is equal to 4. Then you will get P of x equal to e raised to minus lambda into lambda raised to x divided by x factorial, where x equal to 0, 1, 2, so on infinity. Now the first sub question is probability of doctor is free, and probability of doctor is free means there is no patient. No patient means probability of x equal to 0, because we have considered x such that the number of patients visit the doctor. So doctor is free means there is no patient. No patient means x equal to 0. Therefore, in the PMF, put x equal to 4 and simplify. That is probability of doctor is free, which is equal to e raised to minus 4 as it is into 4 raised to x, where x equal to 0, divided by x factorial means 0 factorial. Now this e raised to minus 4 write as it is into 4 raised to 0 is 1 divided by 0 factorial is 1. It is nothing but, if you simplify further, then you will get e raised to minus 4. And e raised to minus 4, you can observe for lambda equal to 4 in the Poisson distribution, you will get e raised to minus 4 value is nothing but 0.0183. And that is nothing but the probability of doctor is free is equal to 0.0183. Then we have the second sub question, that is probability of more than 3 patients visit the doctor. More than 3 patients visit the doctor, we can write in the notations form as probability of x greater than 3. More than 3 means it is strictly greater than 3. Probability of x greater than 3, and greater than 3 means we know that the range of Poisson distribution is 0, 1, 2, so on infinity. Here greater than 3 means x equal to 4, x plus x equal to 5 plus x equal to 6, so on up to x equal to infinity. Now theoretically it is not possible, practically it is not possible to find the probability up to infinity, but we know that the total probability is always equal to 1, so that probability of x greater than 3 we can write as 1 minus probability of x less than equal to 3. You can observe here we consider strictly greater than 3. So 3 we have not considered here. That means we have to subtract probability of x less than equal to 3 from 1, and then you will get probability of x greater than 3. We will simplify this further. Therefore, probability of more than 3 patients visit the doctor is equal to 1 minus probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. Now, in the PMF, put x equal to 0, you will get, okay, next step you will get 1 minus in the bracket, put x equal to 0, that is e raised to minus 4 as it is. Instead of x, put 0, that is 4 raised to 0 upon 0 factorial, plus put x equal to 1, that is e raised to minus 4, 4 raised to 1 upon 1 factorial, plus put x equal to 2, that is e raised to minus 4, 4 raised to 2 divided by 2 factorial, and at the end put x equal to 3, you will get e raised to minus 4, 4 raised to 3 divided by 3 factorial. If you simplify this further, you will get 1 minus this e raised to minus 4 value. This value you will get from Poisson distribution table, and which is equal to 0.0183 into 4 raised to 0 is 1 divided by 0 factorial is 1 plus e raised to minus 4, that is 0.0183, 4 raised to 1 is 4 divided by 1 factorial is 1 plus e raised to minus 4 is 0.0183 into 4 square. 4 square is 16 divided by 2 factorial, that is 2 into 1, it is equal to 2, plus e raised to minus 4, that is 0.0183 into 4 raised to 3. 4 raised to 3 is 4 into 4 into 4, and which is equal to 64 divided by 3 factorial. 3 factorial means 3 into 2 into 1, which is equal to 6. Then you simplify further, you will get 1 minus. You simplify this, you will get 0.0183. Then simplify this, you will get 0.0732. Simplify the next term, this term, you will get 0.1464, and plus you simplify the last term, you will get 0.1952. Then add these bracketed quantities, you will get 1 minus the addition of bracketed quantity, you will get 0.4331. Then subtract this term from 1, you will get 0.5669. Therefore, the probability of more than 3, not doctor, here patient, more than 3 patients visit the doctor is equal to 0.5669. More than 3 patients visit the doctor is nothing but 0.5669. That is the solution for the second sub question. So these are the 5 mark questions on Poisson distribution. Next class we will solve some more examples, but today's the second example is a car hire agency has 2 cars. On an average, there is a demand for 1 car during a particular hour. What is the probability that first sub question both the cars are free, and second sub question some demand is refused? Here in the solution, let x denotes the demand of the car. Suppose there is no demands, then x equal to 0. Demand for 1 car, x equal to 2. Demand for 2 car, x equal to 2, and so on up to infinity. Therefore, x follows the Poisson distribution with parameter lambda equal to 1. Why it is lambda equal to 1? Here it is given on an average there is a demand. On an average there is demand for 1 car during a particular hour. So lambda is equal to 1. Therefore, we can write the PMF, that is P of x equal to e raised to minus lambda into lambda raised to x divided by x factorial. In this PMF, put lambda equal to 1, you will get e raised to minus 1 raised to x upon x factorial, where x equal to 0, 1 to so on infinity. Then we will solve the first sub question, that is both the cars are free. That is probability of both the cars are free. Both the cars are free means there is no demand for the car. That is probability of no demand for the car. No demand for the car means probability of x equal to 0. Now we have to put x equal to 0 in this PMF. We will get the required answer. Therefore probability of both the cars are free, which is equal to e raised to minus 1 as it is 1 raised to 0 divided by 0 factorial, which is equal to e raised to minus 1. This 1 raised to 0 is 1 and 0 factorial is 1, which is nothing but e raised to minus 1. And e raised to minus 1 from statistical Poisson distribution table you will get 0.3679. That is the probability of both the cars are free is nothing but 0.3679. Then we have the second sub question, that is probability of some demand is refused. When the demand can be refused? Because the car hire agency has only 2 cars. If the demand is more than 2 cars, then we can say that some demand is refused. That is nothing but probability of demand for more than 2 cars. If the demand for more than 2 cars, then some demand can be refused. And more than 2 we can write it is probability of x greater than 2. Greater than 2 means probability of x equal to 3 plus x equal to 4 plus x equal to 5 and so on up to infinity. Practically it is not possible, so we can write 1 minus probability of x less than equal to 2. Remember x less than equal to 2 because here in the previous step it is x greater than 2, strictly greater than 2. So it is nothing but 1 minus probability of x less than equal to 2. We will simplify further. You will get 1 minus less than equal to 2 is nothing but probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Now in the PMF put x equal to 0. Next step is 1 minus in the bracket e raised to minus 1 as it is 1 raised to 0 divided by 0 factorial. Then put x equal to 1 in the PMF. You will get e raised to minus 1 raised to 1 divided by 1 factorial. Similarly put x equal to 2. You will get e raised to minus 1 raised to 2 divided by 2 factorial. Then simplify further. 1 minus e raised to minus 1 from statistical table you will get 0.3679. 1 raised to 0 is 1 and 0 factorial is also 1 plus e raised to minus 1 is 0.3679. 1 raised to 1 is 1 divided by 1 factorial is also 1 plus e raised to minus 1 that is 0.3679 into 1 raised to 2 is 1 divided by 2 factorial that is 2 into 1 is nothing but 2. Simplify further, you will get 1 minus, you simplify this, you will get 0.3679. Simplify the second term, you will get 0.3679 and simplify the last term, you will get 0.1839. Then add these bracketed quantities, you will get 0.9179. That subtract from 1, you will get 0.0803. Therefore, the probability of some demand is refused is 0.0803. This is the required answer for the second sub question. In the next class, we will solve some more 5-mark questions on Poisson distribution. Thank you.